One of the biggest challenges organizations face when developing generative AI technologies is choosing the right model for their needs. As a result, at Caylent, we often find ourselves tinkering with prompts across multiple models simultaneously. In these early stages, prompt engineering is more of an art than a science. We're not yet trying to write fully crafted evals, but we're just trying to explore the problem space a customer presents us with. We created Bedrock Battleground to help us rapidly iterate in partnership with our customers on prompts in the pre-sales process. We've used this tool across hundreds of customers and calls to help us quickly experiment with multiple models and uncover their trade-offs. We've included helpful visualizations as well, so customers can quickly understand those trade-offs. This intuitive tool lets everyone in the Caylent organization try their hand at prompt engineering, and now we're excited to release Battleground as an open source offering you can deploy within your own organization. Let's take a look at a few use cases. For instance, healthcare organizations might be looking to automate the conversion of unstructured text into structured text to be used with databases. So I'm going to use a prompt here, and I've got Claude 3.5 Sonnet version 1, I've got Llama 3.2 90 billion instruct, and Claude 3.5 Sonnet v2 all up on my screen, and I'm going to go and paste in this prompt, which is asking to convert these notes that a doctor may have taken and convert them into JSON that we could store into a database. And we'll see as the Battleground goes out to each of these models that very helpfully, Claude 3.5 Sonnet v2 is returning JSON because we asked for JSON, and it is only returning the JSON, which makes parsing the output a lot easier. We can see the Llama 3.2 90 billion instruct model is returning some text, some very well-formatted JSON, but it's consuming additional tokens. And then we can see 3.5 Sonnet is returning the JSON with a little bit of preamble, which is less desirable. And we can helpfully compare the differences between these by hovering over the little graph icon in the bottom right corner here, and we can see what the cost of each of these was. So you can see that the Claude 3.5 Sonnet v2 models were about 5 times more expensive than the Llama models, but the results are roughly comparable. And the time taken is comparable between the two Sonnet models, but the Meta model takes quite a bit longer to return its result. Another example we could explore, and we'll use the same models for this one, imagine you have a list of CSV trades that you want to enrich into a better format. And you can see, as we pass this in, the Claude models immediately take off and they're writing. The Llama model picked a very different format from the Claude model. It's got the trades, and then it's using Markdown format to serve all of these. And you can see that the Claude models are preferring brevity. They're trying to preserve a number of tokens, but the differences in the choices made by each model are interesting, and you can tune the different prompts. So while we've only shown all the chats being synced so far, you can also unsync these chats so that I could reprompt Claude 3.5 Sonnet v2 to continue. So I could say continue here, it would continue doing all of the rest of the trades, it would continue counting the total number of tokens down here, as well as the per message tokens at the prompt up here. All in all, a very interesting way of comparing these models. So with tools like Bedrock Battleground, we help our customers make the most of their generative AI investments. If you want to turn your generative AI ideas into impact, get in touch with us. And I hope you'll check us out on GitHub and feel free to contribute.